Machine learning. Okay. Let me show you how to identify what type of machine learning is with respect to the problem statement and data set. Okay. These two things are really important to determine what type of machine learning we have to select. Okay. So observe this data set. First of all, observe this data set. We are having six different columns: age, sex, BMI, children, smoker, region, charges. Okay, we are having these six different types of you know columns. So here the problem statement is what? This is what really important. What is the problem statement? So here the stakeholder or business people is willing to predict the insurance charges based on these values. Okay, they really wanted to predict. So it is a collected data set, let us say from last year or last 2 years data set from different regions. Okay, this is a collective data set, and they really wanted to predict the price of the insurance. Okay, price of the insurance that can charge from the customer or a person or an individual according to these values. Like for example, in future, age age of the person is 45 years, and he is a male person. Let us say BMI is let us consider 33, 34. Okay, BMI is 34. Children, yes, two children the person is having. Okay, and smoker, yes or no, means let us say yes, no. Region is southeast. Okay, now what can be the insurance price of these values? This is what the stakeholders or business people really would like to know from this available data set. Okay, from this available data set. See, if we go for traditional programming, I already mentioned that it is very, very difficult to mention ranges and these things, because whatever is there in the data set is fine, but sometimes we really going to calculate the, what sometimes the data set which is not at all existing in the current data set, but still we wanted to predict the most appropriate values. In that times we need something or some technology that can identify a pattern, mathematical pattern or dependency of the variables, and then can predict the final variable. So that is what machine learning is. So here what I would like to predict: price or charge. So this is what the output label then. Okay, so mention your output label. Output, expected output label is what? Charges. And then inputs are then inputs. Inputs are as of now the inputs are these four, right? Okay. So now again focus into the output column. So what is the data type? So what is the data distribution actually? Data distribution. Data distribution is what? Okay. So this is also another important. What is the data distribution? If this data distribution is generally control X, let me derive here. If this data distribution is if this data distribution is continuous, array, continuous, discrete, then classification. Okay. Now, now understand the logic here. Okay. So whatever may be the problem statement, okay, whatever. So if you wanna do machine learning, the first step is to get the problem statement very clear. In this problem statement, the stakeholder or the business people really would like to know the price of the insurance or charge of the insurance based on these values. Then again, identify the output column in your data set. Output column is charges. Then identify the distribution, how exactly it is distributed. I already told you in EDA, right? And also in feature engineering, there are two types of distributions. One is discrete distribution. Second one is continuous distribution. In probability also we discussed about this, discrete and continuous. So here charges, how it is exactly arranged, continuous, right? It is not discrete. It is continuous values are. So that is why if it is continuous, then we have to choose regression algorithms. Okay, regression based algorithms. If it is discrete, come back to this data set. Okay, PIMA India data set. Here, the output column is this one. This is what the output column, right? So here the output column, how it exactly defined. Here it is exactly defined in terms of discrete. So discrete means then we have to choose classification type of algorithms. Is my point clear? Is it clear?
Yes, Ishwan.
Can I get a quick confirmation from others also? Because it is very, very important concept so that you will define which type of machine learning model. Okay, great. So shall I consider it as yes from other side, others also? Yeah, Ranjit also mentioned yes. Okay, cool. Yeah, Gauri Priya also yes, and Prajwal also yes. Then Mushraf is also yes.
Yes, Ishwan.
Great, great. So this is the way how you can easily define what type of machine learning model that we are going to use. Okay. So now we are discussing about regression. Regression means remember this point. Regression means whenever you are solving regression means your output column is always will be continuously arranged. It will always arrange in a continuous way. Then we can take a regression model. Okay. Then we can take some regression algorithm. Now, let us go back to this scikit-learn. sklearn is what library. It is same like NumPy pandas, but scikit-learn I already told you yesterday. Scikit-learn can help you to do machine learning related stuff, both feature engineering and machine learning also it can do. If you come to this site, it was developed by Google developers and it is also maintaining now by Google only. So this library, if you come to this library, you can see regression, classification, clustering. These two belongs to supervised machine learning algorithms. Why it is supervised? Again, remember this point. Supervised means you will have labeled data. Labeled data means you know the input output pair. If you don't have any output pair, only input pair, then it is clustering. I mean, clustering means unsupervised machine learning. So here we are dealing again regression. The reason is, I'm repeating, the output column is continuously arranged. That is why we are now going to learn about regression. So if you take regression, supervisor learning, it is anyway we know that. Here you can see what are the linear models that are available. See, linear models are ordinary least square ridge regression and lasso regression, multi-task lasso, elastic net, multi-task elastic net, least angle regression, Lars lasso, orthogonal matching, pursuit, and all such library. I mean, all such are linear models. These are all useful for linear models. And linear and quadratic discriminant analysis, we also have some other algorithms. And kernel-based ridge regressions, we are having support vector machines algorithm, regression and classification, and stochastic gradient algorithm, nearest neighbor algorithm, Gaussian process, cross decomposition, nav base, decision trees, ensembling, multitask, feature selection, semi-supervised, isotonic, then probability calibration, neural networks. So till here, these are all deals with supervised learning only. Here you can see supervised learning. It involves both. Okay, classification algorithms also, of course, it is there inside here only. Okay, it is a club of both supervised and sorry, it is both club of classification and regression models. But these many models are there. Okay, don't think these are enough. Okay, there are many more may come. each time. That is why this field, data science field, is always continuously learning. See, imagine in machine learning and that too supervisor learning only having these many algorithms means deep learning how many it will be, NLP how many it will be, LLMs how many it will be. There are plenty of algorithms are there. Okay, every algorithm is unique. Every algorithm will have their own mathematical imputations. But do we actually have to learn all these things? The answer is it depends actually. It depends. Usually, what are the most common approachable ways you can learn in this curriculum, and remaining things you can explore one by one. Okay, but it is always a good thing or a very great skill if you can learn all the algorithms. Okay, obviously, if you know more means then obviously you will be more demandable and commandable. Okay, you will become easily subject matter expert in machine learning or subject machine learning lead, machine learning engineer. You can easily become. Okay, so if you know every algorithm and how it actually performs, and if you can answer any kind of question related to that specific machine learning algorithm, then definitely you will be a subject matter expert in machine learning. Okay, here what are the things that we are going to learn is multiple linear regression, simple linear regression, two things, and we directly jump to classification algorithms. Okay, so we will not discuss many more. What are the most common ways? See, here you can see regression. What are the most common ways? This is the most common way, regression. So this is what we are going to learn. Okay, so regression and then classification algorithms. Okay, yeah. Come back to here, linear regression, linear regression. And now, so let me show you one important formula you might have seen many times in mathematics. So let me take the paint and explain. Yeah. So have you ever seen this mathematical formula mx plus c? If yes means, can you unmute yourself and say yes? If you ever seen this formula? Yes.
Yes,
Yes.
Ashwin.
Yes,
Very
Ashwant.
good. Very good. Very good. I can hear. Like you already have seen this, right? This means here, if we plot this one, this will be x-axis, this will be y-axis, and this will be the line. Y determines, c, y is equal, this is what the equation of y is equal to mx plus c. C determines y-intercept, where exactly this line touches y. That is what C. Then M determines slope. M determines slope, right? And X determines X point. Then Y determines the Y point. If you want to tell about Y points, any future Y points, simple. We can just drag and touch this line, and then we can get that Y value. For example, I wanted to know if X value is this, then what is the suitable Y value? If I have a linear regression, if I have a mx plus c line, then I can go and touch this line and draw a perpendicular line on y. Then where exactly y is meeting, this is what the equivalent y of x value. Got it? So now what we are going to learn is the same thing. Okay, same concept that now we are going to learn easily. Okay, so here first thing is in regression there are again two things: simple linear regression, simple, and multiple linear regression, multiple. What is the difference between simple linear regression and multiple linear regression? Is very easy. If your data set, if your data set is having two columns, where one column is output column and one column is input column. There are only two columns are there. One input column is there and one output column is there. Then this output column again, it is continuously arranged. Remember this point. It is continuously arranged. Then we can go for simple linear regression. simple linear regression. But in reality, tell me, very, very few cases, right? We have only one column as input and one column as output. Obviously, many cases, output column always will be one, but input columns one cannot determine much things. So that is why if we have more than one input column, then that is what multiple linear regression is. Multiple linear regression means simply like if we are going to have more than one input column and output column always will be one in any case in regression. Okay. So let us understand about simple linear regression. The same concept will work for multiple linear regression also, as we are going to increase the number of columns. That is the only change. If we have simple linear regression, then we are having one input column and one output column, right? Just now I told you. So input column let me consider as X, and output column let me consider as Y. You know how to plot these X and Y. So like let us say these are the points. These are the points of X and Y according to the data set. Let me have a data set. It is the data set. It will tell you if your age and insurance policy or insurance, what is that? The price, insurance price. If your age is 23, you have to pay only $16,000 per year. Okay, let us consider any number. Okay, random number. Okay, if your age is 33, then you have to pay 25,000. So as age is increasing, insurance um, uh, policy number or policy price is also going to increase. This is what the data set. I will consider age as my x-axis, and I will consider insurance price will be y-axis. Okay, so just taking this x value and y value, I just plotted. These are the points. Let me consider these are the points. So what is the main goal of linear regression is to predict or to draw a perfect linear line that can touch most of these points. That can touch most of these points. The mathematics behind linear regression is it is very see machine learning is simply I already told the system has to identify the math pattern behind the data set, right? Pattern in the data set. If machine can identify or determine the pattern correctly, then like we can easily predict the future values. How it is possible? How the pattern can be predicted means we have to use mathematics. With the help of mathematics only it is possible. What is the mathematics behind linear regression? That is what we are learning today. So linear regression behind the mathematics is where is my cursor? Yeah. Behind the linear regression, what is the mathematics is y is equal to mx plus c. We know that how to draw a equation of a line between x and y. If I can plot a perfect separating line or perfect line that can max cover all these points, then if I have this line, then future value, see up to here only x values are plotted according to the data set. Let me have future value 55. 55 is not there in the data set, but I wanted to predict if age is 55%, in that case, what can be the insurance price then? Then in that values, if I can draw a perfect straight line, then definitely I can draw a perpendicular line according to this line. So wherever it touches the y axis, that is what the value machine going to predict for this x value. Is this point clear why it is really important to draw a straight line which can cover most of these points? Is that clear? Is that clear? Can I get a quick confirmation?
Yes, Ashwant.
Yeah, very good. So then now tell me, in a process of this one, in a process of getting the most accurate line or most suitable line, of course it is in reality the data points can alter there and there. It is sometimes it is not possible to draw the perfect straight line that can touch every point, but at least close to all. So let me take points now. So this is x-axis age, this is y-axis insurance price. So I am having a points like this. Okay, so let me take different colors of lines. This is line 1. This is line 1. This is line 2, L2. This is L3. Okay, now tell me, out of these three lines, which line you're feeling is the most appropriate line according to you?
With line 2.
Line 2, right? If you observe line 2, you can identify that it can cover most of the points, right? So the reason is, like, machine learning means here the mathematics, according to the mathematics, it can draw some random lines. And how can we define in reality line 2 is the best one? Of course, by visualization we can easily tell, but mathematically how it is possible means there comes a concept called error. Comes a new concept called error. What is this error? Error means the difference between predicted value and the actual value. What is the predicted value? According to this line 2, this is this line, entire line, whatever the points on this line are predicted values. For example, this is the line 2. Okay. So in this line 2, actually x value, this, if you talk about this particular point, because this point is not touching the line, right? So if you talk about this point, this x value is this much and this y value is this, according to this particular point. This is what the actual point, what we have in the data set of age and price. But if you observe, but according to us, according to the mathematics, here it is drawing a straight line. According to the mathematics, this same point is this much. You can observe the bold lines of this x is same, but the y value is different. It is predicting, it is different. Okay, according to the straight line, this is what the x and y values, but according to the actual value, this. Then subtract these two. Okay, subtract these two y values, y predicted minus y actual. If you do the subtraction, if you are getting minimum or zero or minimum, so that is what the most appropriate line. Which line is having all such errors or minimum, then that line is very good. For example, if you talk about the orange line, same line, if you talk about the orange line, if you consider this particular point, if you consider this particular point, the actual value and the predicted value both are same. So the error is zero. If you consider this point, error may be some 3, difference of 3. Y predicted minus y actual may be 3. Here maybe 2, maybe 1. Here this point it is 0. This point is 0.5, very near. Same way, calculate the green line. Calculate about the green line. Errors. Calculate about the green line. Calculate about the brown line. All three different errors calculate. And whichever line gives you the least errors as, in the entire lines, which errors are very minimal, that is the most effective line. That is the most accurate line. We have to consider that most accurate line. Is that clear? Is that clear? What the concept of error is clear to determine how it is helping us to determine the best fit line. That is what the best fit line. Is that point clear?
Yes, Ashwin.
Yeah, great. So let me show you small content. It is having this particular module is having very good explanation of the same concept with the help of lines. You can see. See, first thing it is considering this line. Okay. These are the x-axis points. These are the y-axis points. First line it is considering like this. Second, yeah. So these are the three lines considered. Let us say the first is red color, brown color, and green color. And then we are calculating the first thing is errors. For the first line, the perpendicular, the vertical line is there, na? Here you can see this particular line. Array, this I will short it and then keep it here. Okay. So this particular line is there, right? The red color, nothing but model 1. Here it is explaining us as a model 1. Okay, model 1 line is this. So we are calculating errors for the model line. You can observe this is the actual value and this is the predicted value. So where we are getting an errors? Errors are very, very high, isn't it? 74, the difference between these two. Then we are calculating about the next line, model 1. Okay, here you can see the errors are very minimal. When it compares to the first model, the second line is somewhat better. Now we go for third one. Now third errors are even better. So likewise, whichever line gives you the minimal errors, we have to pick that one. Okay, we have to pick that particular one. Here you can see if we sum of all those errors, which one is giving very less? Model 1 is really giving us the less values. So that is why model 1 is good, is a good fit line or best fit line. Here we can see the best fit line. Okay, so this is the way to determine, and also how exactly it calculates means we are already known to this problem. We are already known to this formula. That is what y is equal to mx plus c. Here instead of mx plus c, here we use in machine learning sometimes beta naught plus beta 1 x1 plus epsilon. This epsilon is nothing but an error. Okay, always one error is always will be there in data sets, and we are assuming this is to be normally distributed with a constant variance. I already told you, right? Normally distributed, why it is important to talk about more is all machine learning algorithms assumed the error is to be normally distributed with a constant variance. That's why error will be there. It is not that we have to add that as a value. It is just that we have to consider that is there is an error also included in the formulation. Okay. Okay. Let us come back to our uh, paint. Yeah. So the main goal is y is equal to beta naught plus beta 1 x1. Beta 1 naught is nothing but c. This is the same formula if you can refer mx plus c. What is x referred to is beta 1 here. It is here m. That means beta 1 is slope. Okay. So you know how to calculate the slope, right? So that is what we can say. We are having formulations how to determine the slope and how to determine this beta naught also. If you know the beta naught and beta 1 values, for example, beta naught is 10. Let us consider beta naught is 10. Beta 1 is 5. Okay. So the line is perfect fit line is this. Okay. For this line, I got beta 1 is 5, beta naught is 0. I wanted to predict the future value. So x1 is nothing but I wanted to predict whatever I wanted to predict. That is what x1 is. Let us say 10. Now, can anybody determine what can be the y value? Let us say x is 10. Then what is this perpendicular y value? How to determine is behind this is what the thing is working. We have to substitute these values inside the formula. Can anybody tell me what can be my y when x1 is 10, beta 1 is 5, and beta naught is 10?
55 Ashwin.
Let me calculate beta 1 x1 plus beta naught. This is what the formula. Beta 1 means 5 into 10 means 50. 5 tens are 50 plus beta 1 is 5. Yes. Then, sorry, beta naught is 10.
Beta
Beta
naught
naught
is
is
10.
10. Yeah.
That's
Then,
60, sorry.
yeah, then 60 it is. Got it. Then it is 60. So 60 will be the y value. If that means the end goal of linear regression is to find these values, beta naught and beta 1. Beta naught is also called as y-intercept, I told. Beta 1 is called as coefficient. Beta 1 is called coefficient. So now this is a simple linear regression. Simple linear regression means you will only have one column. But if we have multiple columns, then what is the way this formulation going to change is y is equal to beta naught. No matter how many columns we have, all the time we have only one y-intercept, but instead coefficients will get changed. X1 plus beta 2, x2 plus upsilon. How many columns we have? That many beta n's and that many xn's. For example, in this particular problem statement, we are having, okay, age, this particular column sex and BMI, children, smoker and region. So in future values, let me say the beta naught value is B naught. I will say B naught is nothing but beta naught. Okay. Beta naught is beta naught is 10. Okay. Then how many columns we have? 1, 2, 3, 4, 5, 6 columns we have as x parameters, right? Then beta 1, beta 2, beta 3, beta 4, beta 5, and beta 6. 1, 2, 3, 4, 5, 6. So beta 1 is 2, 2, 2. To ease our calculation, let me consider a small values. Okay. Now here age is 15 years age. Okay. Here 0, 1, I can consider a right sex column, either male or female. BMI, let me consider 20. Children 0. Smoker 0. Region also 0. Now tell me what is the y then? What is y? What is y then? Calculate carefully and tell. Let me know. And the formula here for your simplicity, again, I will give you beta naught plus beta 1 x1, okay, plus beta 2 x2 plus beta 3 x3 plus upsilon beta 6 x6. So that is what the y value. Okay. Now, can anybody let me know? So what will be my y? Anybody trying? Hmm? Okay. So let me only answer that. 10, beta naught is 10 given, and beta 1 is 2 and x1 is age, right? So 15, 2 times of 15 is 30 plus beta 2 is 2 but x2 is 0. Then beta 3 is 2, 2 times of 20, 40. That's it. Remaining values are 0 means 0 into 0 anything, right? 0 into anything is 0. Then 30 plus 10, 40, 40 plus 40, 80. 80 will be my y value. Okay, 80. 80 will be my y value. This is the way how to predict the future values based on the x values. If you can determine the respective coefficients and y-intercept values, if it is linear regression, the main goal is to calculate the coefficients and the y-intercept from the data set. If you can calculate from the data set, then we know how the y value works. Y is equal to simply beta naught plus beta 1 x1 up to till how many features we have. So those many dependent coefficient values will be there. So we can simply replace them and then we will get the predicted value. So what the value we have to predict, so we can easily get that. Is this point clear? How we got the 80 and how actually predictions will work using machine learning? Is that clear? Is that clear? Yeah, thank you. Okay, so now let us go back and implement this concept. Now let us go back to this slide and then implement this concept and also learn the different things. Okay, here we can see I already given uh, in the notes steps wise. First we have to collect the data and then we have to do data pre-processing, then EDA. I told yesterday, right, the different ways, the data science lifecycle process, business understanding, data preparation, exploratory data, then data modeling. Here we can see the same steps: data collection, data pre-processing, data exploratory data analysis, then model specification. Here, if it is a linear relationship, then y is equal to beta naught plus beta 1 x1 plus epsilon is the error term. And beta naught is in intercept, beta 1 is slope. Then parameter estimation is something like ordinary least square is one of the methods that we can use to get the estimated values of to beta naught and beta 1 by just minimizing the sum of square values. Okay, and here if you can type you will get the complete thing: ordinary least square. Okay, so same thing, least squares, OLS, ordinary LEAST, least squares OLS. Okay, in machine learning or in regression, simply in regression. Okay, let me take some, yeah, this Wikipedia. And this particular lecture is good. Okay, from CentStat. Okay, it's good. If you want, you can go ahead and watch this one. This will help you to understand,
Ah, I'm there.
very clearly. But it is somewhat confusing. I'm priorly telling that it is somewhat confusing with the mathematics and all. But those who are interested, you can go ahead and have a look. So here you can see it is mainly used in regression. Okay, type of linear least squares. This is one of the mathematical approach to estimate beta naught and beta 1 by minimizing the squares residuals. Okay, so those who are interested and keen into the mathematics, go ahead, or else you can depend on the direct function from scikit-learn. Okay, okay, model evaluation we can do with the help of some matrices. Anyway, I will determine you what are the matrices that we have to use and all, no problem. And then we are going to do the prediction. This is the end-to-end, sorry, machine learning process. A simple linear regression is simple. This is the formulation, and we have to have the parameter estimation have to done uh, slope and intercept in simple linear regression. Okay, here least square regression line is what will help us to do minimizing the sum of square differences. Okay, when it goes to the multiple linear regression, then parameter estimations are nothing but beta naught, beta 1, beta 2, beta 3, beta 4, up so on. How many features we have, those many betas coefficients. Then assumptions are nothing but it is a linear. We are assuming that it is a linear regression. Okay, linear relationship will be there. That is what an assumption. Remember these points. So you may have a question, right? How can you determine whether a regression problem is linear or polynomial or quadratically? You have to tell that, see, by default, we assume the data set follows a linearity. That's why we consider linear regression. If we observe that linearity is not there in the data points later on, we will slowly introduce that the concept of polynomials. Yesterday I told you, right, polynomial features we are going to add. Okay, so that is afterwards. But assume we are going to assume that the property is linearity between dependent and independent variables. By the way, what is the dependent and independent variables? So observe this one. So this is what the one we are going to predict. Correct? This is what the column that we are going to predict. then this is independent. This is not, sorry, this is dependent. Charges is dependent on all these columns, correct? All these columns, it is dependent. That is why the target column is always called as dependent column. Each and every individual X values or each and every individual column is dependent. Is my point clear? The difference between dependent and independent, it is very important concept. That's why. Thank you, Mustaf, for confirming. So hope you guys, other guys also clear this. The difference between dependent and independent. Since it is depending on other columns. So for example, if number of children's changes and age changes and smoker changes, the charges will be changed. That is why it is depending on some other factors. Otherwise, every column is independent. Okay. So that is what here it is very clearly mentioned. The relationship between those dependent and independent is linear by default. We assume that. And independence is we are observations are independent. Obviously, every individual column is independent. We assume that is also we assume every column is independent. Homoscedasticity, that is what constant variance of if we have a variance which is constant, that is the concept called homoscedasticity. Actually, this concept comes in time series analysis, homoscedasticity and heteroscedasticity. Usually, constant variance of residuals if we have, then we can call as homoscedasticity. What is this residuals means? Something like errors. Error is also called as residuals. Don't confuse. Error is also called as residuals. What is this error again? Don't confuse again. Error means the difference between the predicted value and the actual value. Let me tell again. Here in this machine learning, sometimes the term or terminology will make you confuse. But here residuals is also called as errors. Okay, error is nothing but the difference between the uh, actual value and predicted value. I have described you that thing in picture, right? I mean paint, the same thing. No multicollinearity is also there. These are the four assumptions that we consider before applying multiple linear regression. Okay. So then linear regression model building and evaluation, how it is working is, first of all, we have to select the features, choose the relevant independent variables, then data splitting. I already explained you this concept multiple times. Here we have to, divide the entire data set into two halves, training data and testing data, right? So this is second. Third is model training. We have to train the model on training data set. Here observe this picture. Machine learning model algorithms is applying on the training data set only. That is what the third thing. Fourth thing is obviously once model is built, and then we can predict the new data with the testing data. Here you can see that is also testing. Evaluation is also called as testing is going to done with the help of test data. The same strategy now I will use to construct linear regression model. Then when it comes to evaluation, so evaluation is something like we have to determine or we have to come up with a conclusion whether our model built successfully or not, whether we are getting the appropriate results or not. This is what evaluation. So in order to do that evaluation, we are also having four different ways, four or five different mathematical steps. Some of them are mean absolute error, mean squared error, root mean square error. I will again explain you. I have one good documentation, Medium article. That Medium article will gives you all the differences and then the advantages of using that, disadvantages of using that, when to use that. Definitely that will help you in answering interviews. Okay. The typical questions can come from evaluation also. So these are the four commonly used evaluation matrices. When it comes to non-linear regression is simply you can observe the formulation. Linear regression will have all linearity will be there. You can see beta 1 x1, beta 2 x2, something like that. But in non-linear regression, we will have the polynomials like in degrees, beta 1 x1, beta 1 x2 square, x square. This type of thing we already learned in colleges and in mathematics, linear algebra. But here So we are going to identify the residual parts. That is nothing but the patterns in residual will suggest the non-linearity, and scatter plots also will help us sometimes determine whether we can go for linear regression or non-linear regression. Okay. And another concept is variance inflation factor. Yesterday I have just given a glimpse, but today we'll explain you in detail. This variance inflation factor is commonly called as VIF. It is one of the ways to do multicollinearity. Okay, I mean to check the multicollinearity. If multicollinearity is there, we can have these values as reference. Okay, whether multicollinearity is there or not between the uh, dependent and independent. Anyway, we'll explain you one by one after implementation. If I teach you all these things, you will confuse. But if I start implementing the things, then you will understand. Okay. But before going to the practicality, I just have to cover the theory first and mathematics inclusion first, because mathematics is also involved as a part of your curriculum, I guess. Yes. Let me take this point as a reference. Yeah. Regression, classification covered, supervised covered. Now linear regression. You see, steps of algorithms and then mathematics. And then simple linear regression already covered. Multiple linear regression is what very much focused into. And then model building, how it is done, and then evaluation. This evaluation only here again given at the end of the machine learning. Model evaluation. These are the evaluations that need to be learned. R square and RMSE both comes under regression. Confusion matrix, accuracy, precision, recall, F1 score, sensitivity. These are all comes under other classification. Okay. These two belongs to regression. Okay, so now focus on the screen. So now what we are going to do is we are going to take one data set. That data set is simply like the same data set, insurance data set. Okay, this data set I'm going to take. So these are the libraries are important. Okay, these are the libraries that are important. So now let me divide the library section with the data. Okay, so these are the libraries. I just df.head. Yeah, here you can see the data set. Yesterday, I told you about the different ways to do feature engineering, right? So we can do some steps of feature engineering and EDA. So EDA is nothing but exploratory data analysis. So we are going to exploring the data, and also we will do the data analysis, bit data analysis before going to machine learning. So observe how I am performing. So first I'm taking the data set, and then I just read the head part. That means top five values. Then what I'm going to do is I'm going to know about information of the data set, whether there are any null values are there or not. So I can see there are no null values because there are total 1338 rows are there. All rows are, every column is non-null value. And also I have to cross check whether age is really integer or not, and female is a string, and that means object or not. It is float only, and it is integer only, and this is again object, this is again object, and this is again float. Okay, perfectly aligned according to the data points. Okay, and now so I further have to check that is there any still null value if I'm missing in the info. Sometimes we may go in a fast eye, we can miss, right? That is why I mean we may miss, but if we go and check this function, definitely it will give us the best value, like whether there are null values or not with the help of them counting the null values. Okay, so I don't have any null values. Fine. Then if I observe that there are three different objects are there. Three different objects are there. So I have to identify whether these objects are categorical data or not. Okay. Now tell me, anybody, sex column, region column, smoker column, are these columns are categorical or not? Yesterday we told about, I mean, we discussed about categorical data. Are these columns are categorical? Yes, these columns are categorical. Okay, if we know that these columns are categorical, then we also wanted to know that how many unique values are there. Okay, how many unique values are there? Knowing unique values, knowing the unique values, df. So which column that you want to know? First is sex column, gender column, then unique value underscore counts. If you use this function will help you. Sex column is having male and female, only two different values. Males are 676, females are 662. That means almost same. There is no much difference between the categories. So if we have only two categories, then that is called as binary. Remember these terms, okay? If we have only two values in a categorical column, that is called binary. Okay. Then let us go ahead and see other columns also. We are also having smoker. Now someone have to answer me. Smoker dot value underscore counts. Let me zoom in a bit. Yeah, this might be helpful to you. Yeah. So which here you can see the category smoker is having only two values. Then what name can I define this? Can anybody quickly?
Can you repeat the question? Yes.
Yeah. So smoker is having only two values. Then what type of categorical column it is? How many types of categorical columns? There are three types. Yeah, there are three types. Remember this thing. There are three types of categorical columns. There are three types. Remember this. Three types of categorical column. Categorical. There are binary that reflects only two categories. Ordinal. That means if there is any order. Nominal. NEIGHT are neither binary nor ordinal. Okay. So remember these things. Categorical columns are nothing but an object is being assigned to the columns. Okay. So categories. Which columns are having categories? That is called categorical column. Remember that. Object means it may be text data, but we don't want the text. Comes under category. Category means categories. It should be categories. Will be involved. Okay. So if there are only two categories, that is called as binary. Here you can see in sex column only two categories are involved. So that is why sex column is a binary. In the same way, what is then smoker? That is the question.
Is that a nominal or binary?
You have to
It
tell.
could it could either be a nominal, I guess, Seshwan.
No, it is not nominal.
Then it's binary only.
Yeah, don't confuse. That's why like you may confuse. That's why. See, observe how many. There are only two. That's why it is called as binary. Now you have to answer me again. Df of region dot value underscore count. And also remember these functions. Okay, it will help you quickly. Uh, okay. Now you have to tell me this region is what then?
Nominal.
Nominal, I think.
So why? Why are you thinking it is a nominal?
I
It's
think
not like it's having more than two, right?
That is why it is not binary. Okay, then why it is not ordinal?
It has like some particular.
Yeah, because it doesn't have any order, right? It is not having any order. That is why you are thinking it is a nominal. Yes, you are right. Okay, it is nominal because uh, ordinary means always it should be large, medium, high, first, second, third. Some order should be there. It is not order. It is some names being assigned northeast, northwest. Sometimes these names can be also assigned as first zone, second zone, third zone, fourth zone. Zone, zone one, zone two, zone three, zone four. Those are not orders. Those are names of the zones. Road number one, road number two, road number three, road number four. That doesn't mean that there is an order between the roads, right? That is simply name given to the road. That is as simply counting and then we are giving. But first, second, third, this is an order. Some grades are there. A grade, B grade, C grade. Grade is something like it is determined with a something range. If any student scores this much, then it is considered as grade one, something like that. And also small, medium, high salaries. Their range is even involved there, correct? So that is why it is called as ordinal. But here it is nominal because it is not been assigned to any range. Correct? Now, is it clear? Is it clear now? So the difference between these three categorical, it is very important. Okay. So because this is the way many times you observe data set involves the names also. Okay. Not all the time numbers, names also it is there. Then you have to know how to deal them. Okay. How to deal simply the categorical data. Yesterday I told you there are three ways. So please refer every day's class from now onwards because it is important because continuity is going to build every day. So simple, like you need not to refer entire the video session because it has been 2 hours. Sometime you may get distracted. I can agree because nowadays if we see the subconscious memory power is only just 5 seconds. Means 5 seconds only we can someone can concentrate after 5 seconds immediately one or other thought can come and disturb us. It's fine. But please refer the notebooks. That's why I'm creating notes in such a way can be understandable to any level of student. Okay, the main notes I'm providing to you so that the notes also, if you observe, you will not get like this anywhere. Okay, because here I preferably created separate to this batch. Okay, every time I create new notes because it depends on the type of people I'm handling. If I'm handling graduate peoples or if I'm handling non-technical people, then I have to consider examples accordingly, right? But according to your batch, I define like this because you need approaches, you need step by step and then approaches because soon you're going to deploy to jobs, right? Definitely there, this is what really important. That is why you can focus on the steps. Okay, you can focus on the different ways. Okay, let me take open notebook, feature engineering. This is what the last class. Let me show you again, feature engineering. So simply what you can do is every day I'm uploading, though I'm not uploading the video because of the space really. Yesterday also I tried to upload, but it is kind of 6 GB, both two videos. Don't having that space, that much space in Google Colab or Google Cloud. I even tried uploading the YouTube, so I don't know. It is also not getting accepted there because since I did not upload earlier. Okay, here you can see. Here I provided very clearly in handling the categorical data. We have three things: one hot encoding, label encoding, and target encoding. I also provided what are these three. Now I will show you practical thing how and when you can use those concepts to impute or to do the categorical imputation. See, if you see binary values are there. If your categorical column is binary, then you can use either one hot encoding or else label encoding. It is anything is fine. Okay. So now what I'm going to do is I'm going to do one hot encoding. Okay. So for my these two columns, or else I will do one thing. Sex column I will go and apply uh, one hot encoding. Smoker column I will apply label encoding. So that two codes you will get to know. So one hot encoding, how it can be done is you can do it in two ways. One way is here I provided direct code. Okay, go and check this here. You can see this particular code encoder, one hot encoder. Then we are going to drop the first one. Why to drop the first? Also, I told you just to decrease the data set. Even though if we don't drop, the same thing going to convey even if we drop one. Okay, so the same thing I'm going to use. Okay, or else there is one more step. There is one more way here. That also I provided. PD dot get dummies is also a function we can use. So let me take this one because this anyway I have given here. You can refer this and you can also refer this. Two different things are available means you can decide whatever makes you easy. Get a miss is a function. You can define entire data set or only one column. If you define entire data set means this is the output here. That is also I provided here. Entire output. Sex is having male one column, and we are anyway dropping the first column. That is why female got dropped, and smoker yes and no. The no got getting dropped, and regions there are four. That is why dropping the first one. That is why we are having only three. Okay, got it? So this is the way how to do the get the miss. But if we use only particular column, let me take only one column, that is the first column. Okay. So, so these are the values. Here you can see. Okay. But if I wanted to explicitly mention in a data set, then assign that values effectively like this. Now, if you observe the DF, see, so false, true, false, true. Get dummies will gives you the false true only. Here also you got the false true, right? But anyway, false true also computer can understand 0 and 1. Don't worry. Is that clear how to do the one hot encoding? And we are anyway dropped the first column. Otherwise, we will get again for true one and false one. I mean, male one column, female one column. Here, false means we can understand it is female. Here you can see. True means we can understand it is a male. For example, if you don't want false and true, instead you want 0 and 1, then what is that way? That is called, target encoding. Target encoding. That is the third step. Here I told you how to do the target encoding. Okay. So target encoding is what we are specifically encode based on our desired values. Encoding. Okay, so how we can do that is you can do it in again two ways. One way is grouping them and attaching the transforming mean and all. Otherwise, simple transformation means false means 0, true means 1. That means assign a dictionary. Okay, target values dictionary. If you are not getting anything in between, please let me know. I'm ready to explain once more. Okay, but try to understand. If you have any thing doubtful, please let me know. False as 0 we can give, true as 1 we can give. FALSC, false. Spelling mistake. Okay. This is what the desired value. Once you get the desired value, then go and I already taught you about map function in Python, right? Here you can see the help of map. Okay. So now if you run this one, now it got updated. Is this point clear? We have just seen one hot encoding and target encoding. Both the things we have covered now. Yeah. So remaining left thing is called label encoding. Label means uses the the what we can say uh, rank rank according to the rank. It will itself determine 0, 1, 2, 3. Okay. Here you have to understand according to the domain knowledge. Okay, which one is the perfect encoding? See, if you observe the gender column, male and female, here we can either use target encoding or we can even use one hot encoding, right? And smoker, yes and no. There also same thing, yes, no, male, female, yes, no, pass, fail. These are all comes under same category. Either we can go for one hot encoding or target encoding. I will use one hot encoding again. Okay. Instead of using this gender column, I will go for smoker column. Smoker. Spelling should be same. Otherwise, we will get an error. One hot encoding here we say instead of gender, we'll say smoker. And same code I have to also given Control C, Control V, Control V. Now you can see the updated here head value. One hot encoded smoker. Okay. So gender column completed, smoker column completed. Now region is there. Now we will do this label encoding. For label encoding, we have to determine the label encoder. So label encoder is actually control this. Array, it is not working. In Visual Studios, directly it will take you to the top, but it is not. No problem. See, we will see label encoder. Where exactly label encoder? Label encoder. Here it is label encoder. This is the code we have to use. We have to import accordingly. So for label encoding, one hot encoder anyway we don't require now. Let me use label encoder only. Okay. So instead of categorical label, now I have to mention what is that column that I want to apply the label. Okay, df of region. Okay, here error because extra space is been given. That is why an error. You have to make sure. Now observe this final one. Region column automatically that I removed here in order to show you as an example. That is why I included. Otherwise, I should give instead of one hot encoder smoker directly. I have to replace this column, right? But now I wanted to show you one more thing. Here, only the numerical data only should be there. But here extra we have these columns, right? Anyway, we converted that columns to the numericals. Then we can remove these columns. How to drop the columns also I told you in Panda section. Please refer. But anyway, here also I'm going to explain you. You can use the drop function and mention what are the columns that you want to drop. Here you can see this is the way. Mention that what are the columns that you don't want to be there in the data set, and also in place equal to true for permanent actions. Here you can see the updated data frame. Okay, these are the things. Up to now, is this clear? Now we have done a little bit feature engineering only. Up to now, is this clear? Can I expect any answer from your side? Okay, thank you, Mushraf. Yeah, good. So now we completed that a little bit feature engineering. And one more feature engineering step, if you want to perform, you can do on charges. Because in charges, after point, there are many points are there. If you don't want those many, if you want only two rounding to the two numbers, then you can use this way. Charges is equal to round off, yeah, df dot charges 2. Okay, so these are all different ways. Okay, this is all different ways. Here you can see all points getting 2. Now again, I wanted to know whether there are any outliers are there or not. Outliers identification. Okay, how can I do outlier identification? plt dot box plot, right? Box plot of charges. Yes, there are many outliers are there. There are many outliers are there. Now tell me, use your domain knowledge. Now tell me, now is it necessary to remove the outliers? Is that step is required according to the domain? Can anybody? This will help you, like in what way we have to do analysis in real time. Now is it necessary to remove outliers, or is it okay to keep it as it is according to this domain? Justify your answers also. Come on, anybody would like to know?
I think there are a lot of outliers, so it's better to remove, I guess.
Okay, so Prajwal is suggesting it is good that we can remove the outliers as the number of outliers are more. That is what Prajwal's justification. And is there any other justification according to your thought? Just add a random thought, whether it is right or not. It's okay. I just wanted to know in what way you're thinking. So that I can help you out, like I can uh, give
If
you
it,
or inject you uh,
During
your way of thoughts. Yes, please. Someone is trying to. Mushraf, come on.
even though there are more outliers, so we can't remove all of them, but we can remove like up to the outliers which are above 50,000.
Okay, so base specific to count. So you want to remove. I mean, so,
Yeah.
not all, but some you wanna remove, right? Because there are
Yes, yes,
many.
sir.
Okay. Is there any other answer from either Gauri Priya or the same strategy? Okay. Let me tell you one thing. See, removal of outliers or not, or changing the outlier values to the most specific values is all depending upon domain value, domain thing. How we are going to know? That means, see, go and check that insurance, right? Insurance charges just depends on depends on any criteria or the insurance companies can decide any price. So if I ask this question in the Google, insurance charges are not arbitrary. They are determined by various factors, including the type of coverage, policyholder demographics, and risk assessment being solely at the discriminate of the insurance company. Okay, according to the insurance company, okay, so what they really uh, take into consideration is age, location, and gender. Okay, risk assessment is medical history, lifestyle, driving record, and credit score. And these are the values that, based on these values, the insurance companies will put the number. It is not that, for example, if insurance company X is there, by default the starting insurance policy is some $1,000 or $2,000. Correct? Will you all agree with me? Will you all agree with me? For example,
Sorry, can you repeat?
yeah, what is that, Prajwal? Okay. So, for example, if you are buying any shirt from any website or any company, let us say it can be some popular brands in India like Allen Solly, Van Hussein, okay, Louis Philippe, Peter England. If you're going to buy any one of the, any one shirt from any one of the brands, it is their price. Okay, it is not depending upon anything, right? It is their price. They wanted to sell that shirt for that price. We cannot question why you are selling this at $1,000. Other companies are selling it as $100 only. Then they may tell you that this is some fabric, this is some cotton, this is so and so. The feel is good, the look is good, the fashion is there, and all. But the same values are also available in other companies also. But still, prices changes because it is according to that particular company. They want to their according to their marketing value, they can sell the price to that price, and people should buy for that price only if they really wanted to. Okay, if they really like that shirt, if they really like the feel, touch, fabric, fashion, and all, they can go for that price. Okay, that's why they are fixing their own prices. But when it comes to the insurance companies, yes, that factor is also there. According to that insurance company, yes, they may charge $100 or $200 more, but still they should always depend on age, medical history, and all. If age is between this range, and if medical history is not is very good, medical history is the person is not having any big medical changes and all, it is really nominal, then the price will also be nominal. So no matter what the insurance company in the market, of course, $100 here and there threshold will always be there. Okay, so that is why charges can be you know can be the outliers can be further modified according to, you have to identify the pattern. Okay, so you can do the task because that will take time. I already told you, in the entire life cycle, what is the most time taken processor is exploratory data analysis and feature engineering. Okay, this is what the most time taken process. That's why you can do, if you are interested, I'm leaving it here. So task is identify the prices according to age and medical history values, and do modify the outliers. So just try. This is the task. Okay. So again, let me tell you how to do this task. So you have to identify the prices according to the age groups. For example, ages between 19 to, you divide according to age, according to BMI. Okay, according to children. Children anyway, yes, children is also important, right? If less number of children, then price will be less. If more, so they have to cover for that child also. What if everyone go and admit in the hospital, means they have to cover the range to all the patients or all the members of the insurance policy. right? You can take this consideration also. Region, of course, region also you can consider. But how can you do? I will give you a small example, okay? Based on that example, you can follow and do the remaining things. This is all about, to conditions, right? For example, lock. So df of, let me say region equal to 3. So these are the prices of region having 3. Then what is the minimum value and what is the maximum value? Okay, region 3. Okay, get the minimum value and get the maximum value. Okay, and similarly children. So how to get the minimum value, maximum value easily by using group by also you can do. df dot group by on children, for example. Yeah, children dot, instead of mean, I will go for aggregation function. This is one way. Let me run. Okay. So we got an error. Maybe we are using it in the wrong way. So df dot group by, simply another way you can also do df dot group is equal to df dot group by, then group group dot tsc describe. You will get all. Here you want age, you don't want age, you want BMI. So whatever you want, you can take this. See, according to the children, they already grouped all values you got. I am leaving this particular cell as it is, so that in future, if you want, this code may help you to get the all group by related things. You can take that. Okay. And here aggregation function in pandas section, I already given clearly. So how to do aggregation function. But anyway, here I will show you again df dot group by children dot minimum. If you apply minimum,
Spelling of children is wrong, Yashwant.
spelling of children is wrong, right? CHILD, sometimes TREN. Yeah, thank you for adding that. Yeah, here you can see minimum we got. Similarly, edge gives us minimum. No, here method is wrong. So let me take the help here quickly. Group by minimum, yes, same code. Acha, here I have to use this particular bracket. Yes, now I got it. So here it accepts only one. Okay, minimum, comma, maximum. Now it will work. Cool. Okay, here you can see df dot group by children. Only we are getting minimum and maximum of every column. If you want only price column, then define that price clearly. Define that price clearly. How can you define? So let me also show you, so that in future, if you need such functions, it will really help you. You can take this as a reference. Children, select that particular sub data set, subset of the data. Only children and charges is what I'm selecting, and then applying group by and children and getting aggregative function. Okay, of charges. Got it? So 0 children, minimum price is this, maximum price is this. 1 children, minimum price, maximum price. Define all those things, observe the difference. Okay, so in what way the analyze, in what way the insurance companies are charging according to different parameters, minimum and maximum price, according to children, according to region, according to BMI, according to age. Okay. So in that way, you can also learn the domain knowledge. Those who are interested into insurance and medical insurance, such companies, you in US there are a lot of companies uh, who work for medical insurances, travel insurance, and all such things. Okay, there are many companies are there. So you can also learn their strategies behind uh, fixing some charge. Okay, okay. So now we can continue the remaining topics. So this is all not important. Yeah. Also, I already told you the machine learning, it is the primary assumption is we will assume there is less dependency between the values, right? For example, here it is very clearly mentioned. We will assume that uh, the no collinearity, the independent variables are not highly correlated, correct? That means they are not depending on one. Here you can see heat map will gives you a clear idea. According to this, you know, according to this, but here we have to change the data set. Okay, sorry, df.course. Yeah, according to our output is charges. Okay, according to the output, which values are really dependent or independent, heat map will help us. Okay, so now again another task is to you. Here, note down task. Here your task is note down all your insights here. Okay, insights means what exactly you identified out of this particular heat map, like which categories is having higher dependency or higher collinearity, which are having less collinearity. You can write down all such things here. Okay, so that you will understand in reality which columns are really important to fixing the charge. Okay, so now let us come to this part. Okay, 5 more minutes is required because machine learning will take only 5 to 10 minutes max. Okay, so remaining things is what really taking time. Come to this section. You have done historical data. This part is also over, feature engineering. Now it is time to divide the two different sections, training and testing, how it can be done. First of all, you have to define what are the input columns and what are the output columns. Okay, what are the input columns? So input columns here we are selecting uh, let me take the df of head so that you can answer me. Df dot head. So what are the input columns? These are all the columns. Charges is what I wanted as an output. Remaining all columns I wanted to take it as input, right? Instead of go and typing, we have one more function is there or one more attribute is there, columns. If you go and type this, give this function, you will get all the columns. Out of this, you can take the entire list. You can take the entire list, and this is the way usually I follow to save time. Simply I remove charges. Okay, so that I got all the inputs. Output anyway is charges. So define your input and output, and then you have to divide the entire data set into two halves, training and testing, right? So input values. Now we have two things, input values and output values. Then input training data should be there, output training data should be there. Input testing data should be there, output testing data should be there. That is why we are having four things. Input X train means input columns training and input columns testing. Output columns training, output columns testing. Okay, that is why we are having four different variables, and then train test split is the function which will help us to do training and testing split. X means simply your input values, Y means simply your output value. Then what is this test size? Test size will explain you in what probability that you want to test, or you want to divide a test. So 0.2 stands for here, 0.2 stands for 20% goes to the testing, 80% goes to the training. That is what test size. Random state, I already explained you. It is a random seed. In np.seed, I explained you. Whenever you are using seed, then we will fix that value, and we will, those who are using the same, you will always get the same level of random split. Let me show you. np.seed. Okay. If we fix seed, okay, seed is equal to 21. Okay. Oh, numpy, module numpy. np.seed. Okay. So if we fix some seed value, okay. Anyway, here you can see numpy.random.seed. Okay. If we fix some seed value, and if we use this function called np.random.choice 1, 2, 3, 4, 5, 6. Okay. So now you can observe how this random state works. Now, if I'm running this without seed, just observe, without seed, I may get any value out of randomly, I may get any value out of this, right? I may get any value. But if I'm fixing the random state, random seed or here in pandas random state, in numpy it is random seed. If I'm fixing random state is 42, every time I will get only 4, you can see. So we are fixing randomness. That is what the help of seed or state. Okay, here if we use a random state is equal to 42, then we will fix one random procedure, and we accordingly we will split the training and testing. Okay, it will help you when two members are working for the same team, then you both can fix one random state so that same values you will get randomly. Got it? So this step is completed, right? How to divide two different things, the feature engineered data, into two steps, like training and testing. Then observe, training data we are forwarding to the machine learning model. Now machine learning model is linear regression. We have to call that as an object, and then we have to use this function called fit. There we have to pass only training data of x, training data of y. Okay, input values and output value training data. So this is the way how to do machine learning. That's it. All the mathematics, whatever we learned so far, y is equal to mx plus c, this blah blah blah, beta naught, beta 1, calculation, all such things go away just by using this function fit. Behind this fit function, you can see all, the mathematics will be there. Okay, the calculation of the slope, the calculation of the randomness, all such things will be there. Just we need to use this fit inside the training data. Then linear regression will be built. Okay, so let me show you that. Control X. Let me run this one. You can see, if you can see this thing, memory object, this is what defining us. This particular model is built. This particular model is built. This is the indication. Model is built. Now what we have to do? Now what we have to do? We have to use the test data to get the predictions and then model evaluation, right? To get first predictions first. So to get the predictions means, how to do the predictions means, same model name, linear rig is a model name. We have to use a function called prediction. There we have to use the test data so that we will get the y values, right? Y is equal to mx plus c, you remember, right? So now what we are doing is using the x values. X values means how many columns we have: x1, x2, x3, x4, x5, x6. Okay, using all that values are x1, x2, x3, x4, x6 is not nothing but x test. This x test is passing to that formulation, this particular formulation. Okay, this particular formulation. Now I am getting the y value. Got it? So that I will get the y values. Is that clear? That is why y is equal to we are passing the test data to the predict function so that we will get the y values. So now if you print the y pred, these are all the y values that I got. Okay, these are all the y values I got. But actually, the data set is having the y test, right? The data set is having the y test. Correct. Here we did not use the y test so far. We are predicting the y from x test, but actually y test is available. So if you want to know the error means the difference between the actual value and prediction, that error should be minimum. That is what our target, right? That is what called mean square error. We are just squaring, and then we are doing mean means average. R square is nothing but, here anyway I have some small notes to you. Here you can see the formulations. Okay, the formulations of all. This is what the medium article I just described before. Mean square error is, see, the error is nothing but we are doing the the subtraction of original value from the prediction value and then square. We are just doing the mean means sum of all values divided by total number. That is what mean square error. And then root mean square error means simply we are applying the root over it. That is what root mean square error. And then mean absolute error means instead of squaring we will take the absolute value, means modulus value. And then r square means this is the formulation, 1 minus this divided by 1 minus this, so that we will get the mean r square. Okay, and then we have adjusted r square. This is again 1 minus r square into n minus 1 by n minus p minus 1. You will have all the different things, and also I will forward this anyway. This will help you to get the advantages, disadvantages, when to use, when not to use. This is all you have to remember it. Okay, this is all you have to remember it simply, because mathematicians already proved that this is the way, and these are the advantages, these are the disadvantages. Okay, clear? Now let us come back to here. So only 2 more minutes I will take, not more than that. So these are the r square values and mean absolute value. Okay, r square value will define as how much accurate these two are. Okay, here you can see the value is 0.78. That means 78% it will score. It will give us the right results. Is that clear? Is that clear? Is that clear? 78% it will give us the right answers. Our model so far, the build model, 78% will give us the right answers. Now let us, I will show you how to print the intercepts and coefficients. Okay, so linear model dot y-intercept or coefficient coef underscore. This is the way how you will get the coefficients, and instead of coef underscore, if you use intercept underscore, this is what the y-intercept. This is what the y-intercept. These are called beta 1, beta 2, beta 3, beta 4, beta 5, beta 6. If you go and see X test clearly, X test dot head. So these are the X1. This is X1. This is beta 1. X2, beta 2. X3, beta 3. X4, beta 4. X5, beta 5. And X6, beta 6. If you substitute all these things and plus intercept beta naught, that is the value you are getting as this much. That is the value you are getting this here. But actually, according to the data set of these values, okay, you will also have y value, right? Y test dot head, if you see. But actually, according to the data, this is the value. But according to your machine, this is the what value it is predicted. The difference between 8924 minus 9095. This is what the difference between the error. Okay. So those all errors, if you square it and then mean it, that is what mean square error. If you do root, that is what root mean square error. Then R square will have a different formulation again. Okay, R square will gives you the best results. That is why most machine learning algorithms assigned with linear regression will have the R square as their evaluation matrix. Now it is 78% accurate. Then in future values, how to define? This is the last concept I'm going to cover today. Future values, then how to predict. Then use this function, use this model name again. Use the predict function. Predict function. Then assign the values. For example, these values I wanted to predict. 64. Take the values. Okay, 64. Let me take these values like this. Control C. Control V. 64. 64 is an integer, right? Then comma. That's why. 26 is BMI. 0. 1. Yeah. If you go ahead and print. So this is the value what machine is predicting. In future, whatever values you want to test, you can test all such values and you will get the predicted insurance value. Okay, that's it for today. And this concept is nothing but if you this is an extra concept which you can take it as a reference. If you identified that there are features, there are values which are not following the linearity, then if you go ahead and use the polynomial with degree to start, if not satisfied, then degree equal to 3. Likewise, you can use and how to train and test and split and how to use R square and again how to do. This is all been covered here. This VIF factor anyway I will cover tomorrow. For logistic regression, I will cover that. Okay. Is it clear? Is it clear so far?
Yes, Session.
Yeah. So